context invariant or to make generalization work. Nothing was coming to mind specifically when I was thinking about this off the top of my head, but I don't know. Iran, do you have any thoughts on something like this?
Yeah, actually, people here in the lab before you and I came did work on this.
Oh, cool.
You've heard about Vincent,
Yeah.
the guy from France working with
Mhm.
birded songs.
Yeah.
He did some dynamic filter networks where right before the output layer, you concatenate very long range acoustic features of the recording where your 3-second chunk, for example, may be coming from.
Mhm.
And that removes the acoustic context and
Mhm.
keeps only the signal that you want to identify or classify. So there's a very interesting paper. I can put it in the chat right now.
Yeah,
Yeah.
sure. Thanks. Oh, and this last question, whoops. Do you think that the voice data set could be useful to identify singers in a noisy environment like the streets of Mexico City? This is a really interesting question. I thought kind of when I was thinking through this question, what came to mind probably was if I wanted to do something like this, the process I would take would probably be to first kind of go to some sort of source separation algorithm where I could source separation or some sort of denoising where I could separate out the kind of singing voice from whatever that background noise was. And then from there, if I kind of was able to obtain a pretty clean signal of singing, then maybe we could use a model trained on vocal set for whatever downstream task you're looking to do. So if you were curious about some sort of technique classification or something like that, if you were able to kind of filter that signal down, then I think that vocal set could be successful on something like technique classification, or if it was a really, really good signal, maybe something like the vowel identification, or the even potentially identifying C or F major or something like that. Great. And then another miscellaneous question I had was, what is Siamese training? I was looking for visualization, and then I came across Siamese cat toilet training, which is not what I was looking for about Siamese network training. I haven't actually worked hands-on with the Siamese network, but my kind of understanding is that with kind of this paradigm, instead of kind of having just a single network that you're kind of propagating through and back into until you get your output, you kind of have two networks operating in parallel, where instead of the network kind of trying to distinguish between, in this example where we have kind of two pictures of tigers, maybe we're trying to, we have a class that's tiger versus alligator. So instead of having the model really work to kind of use these adversarial examples to distinguish between what's an image of a tiger, what's an image of an alligator, the model more so kind of is learning what makes two tigers the same by kind of passing two different samples from that class through the model and kind of learning in parallel. And these models apparently can be really helpful when you do have a big class imbalance. So instead of learning what a tiger is not, you're actually kind of more deeply learning specific features about that class. So if we had kind of this super underrepresented class, then maybe we kind of build some sort of architecture like this that could really zero in on the features of that underrepresented class. I don't know, Iran, have you worked with Siamese networks?
I'm working right now with one. You've heard about this model called MDeter that we sometimes buzz around.
Yeah.
So it's a model that does this, but in one branch it takes language understanding, and in another branch takes image understanding. Then when you have a space through these representations, you concatenate them and you use those to do something else. In this case, detection of objects in a picture with conditioning both the text and the image.
Cool.
Yeah. So they're very, very cool for multimodal scenarios, and also for, as you say, so to make the higher order representations of the network that actually do the decision more generalized.
Mm-hmm. Cool. Yeah. Yeah, I definitely recommend people check out I don't know if you want to send the link to the MDeter paper. That was my favorite lab talk this year, was on that one. So would recommend if you're interested in like multimodal learning. Yeah, and then just to wrap up a little bit, so what I'm working on kind of now in the first year of my PhD so far is in kind of the multimodal machine learning space is really hot right now. So whether that's typically it's some combination of text, image, and audio. What I've been working with so far has been audio and vision. So it's kind of an interesting mix of drawing ideas from the computer vision world, from the audio world that I'm a little more familiar with. And right now the project that I'm working on is kind of, the question is, can we train models to learn things about the image or video data using only the audio data? So this picture I have here is kind of a screenshot of a video that from a data set I've been working with that has kind of just urban scenes of cars passing by. And we have kind of stereo audio data paired with these videos. So what we're trying to do right now is figure out, can we train a model to figure out where the sources of sound, aka the vehicles in the scene are? Can we train the model to kind of localize these sounds using only the audio data? So there's some interesting applications in the real world here with things like traffic monitoring, like generally just thinking about how deploying a microphone sensor on any device is smaller and cheaper. So that's kind of some of the motivation for some of this work right now. But I'm happy to answer any questions if people are curious about this too. But a lot of interesting ongoing work in this space. And that's basically all I have. So does anyone have any other questions?
Don't be shy.
If not, it's okay. People sent in really awesome questions. So thanks for
yes,
those thoughtful questions. Great.
Let's give them a couple seconds to think.
Okay.
But while they think, I just want to say thank you so much, Julia, for taking the time. Julia is extremely busy these days, so it's kind of like we resuscitated a dead person and we brought it to present for us. It's that magical because she's really like she's really busy these days, and it means a lot that you're here and you're taking the time to present. So thank you very much for that. But let's see. Don't be shy. Do you guys have other questions, other thoughts? If not, because she's so busy, we can let her go back to her grave.
It's true. When Iran sees me at the office, I look like a zombie sometimes.
That's not what I meant.
Pablo, you had a question?
Yeah, I have a question. In the case of this audio and video classification, do you have any idea on if there's a standard configuration for the microphones, for the audio signals that you can use for every kind of video, or you need to put the microphones in a specific configuration to be able to locate them in the video?
Yeah, that's a great question. So with the data set that I'm working with currently, it's kind of a mashup of two different data sets of these urban scenes. And one of the data sets is set up for a purely stereo recording, and the other one is actually a person wearing a set, like a binaural headset. So that's actually presented some interesting kind of questions as we have been training models on just the data combined, because it definitely seems like the models trained on the binaural data are kind of doing a lot better at the localization tests than just the purely stereo audio, which has been interesting. But yeah, it's definitely something that we're kind of keeping in mind. And I guess with like kind of where to place the microphone, the kind of, in addition to passing the model, just the audio data itself, we're passing kind of the field of view of the camera, where we're kind of assuming this kind of center point of the microphone and the camera, but we do have the angle of the field of view, like assuming you were just kind of straight on to the scene, if that makes sense.
Okay.
Yeah.
And Ahmed Jalsin has a question.
Hi.